All right, so let's talk about acceleration. Our learning objective for acceleration is to define and distinguish between instantaneous acceleration and average acceleration, and calculate acceleration given initial time, initial velocity, final time, and final velocity. So that is our learning objective for the next few slides. So, in everyday conversation, accelerate means to speed up. The greater the acceleration, the greater the change in velocity over time. Average acceleration is the rate at which the velocity changes. So here we have our equation. A is average acceleration. V is velocity, so both are our change in velocity, and T is time. The bar over the A means average acceleration. Because acceleration is velocity in meters per second divided by time, which is in seconds, so time is in seconds, velocity is in meters per second. The SI units for acceleration are meters per second squared, which literally means acceleration is how many meters per second velocity changes every second. Velocity changes every second. So that is our definition of acceleration as well as our equation. And this is an important equation to remember. So remember that velocity is a vector. It has both a magnitude and a direction. So a change in velocity can be a change in magnitude or a change in direction. So we're talking about acceleration. So that means that, for example, down here, no, that's not what I want to do. Down here, for example, a car, say this car pictured over here on this racetrack, a car is turning a corner at a constant speed. It is accelerating because its direction is changing. The quicker you turn, the greater the acceleration. So there is acceleration when velocity changes in magnitude, which that is an increase or decrease. Ooh, that's not what I wanted to do again. That is an increase or decrease in speed, or a change in direction, or both. Both. If there's a change in both, obviously we have a change in acceleration. This all leads us to the fact that acceleration is a vector in the same direction as the change in velocity. The change in velocity. When I move my slides over, it cut out an in. That should be in velocity, change in velocity. So, acceleration, keep in mind, acceleration is in the direction of change in velocity. It is not always in the direction of motion. So when the object's acceleration is in the same direction as its motion, the object speeds up. So here, our acceleration is in the same direction as our change in position or displacement. So this means that velocity has increased. This object has sped up. However, when an object's acceleration is opposite to the direction of its motion, the object will slow down. So here, that should be a lowercase a. Let's pretend it is. Our acceleration is in the acceleration is in the opposite direction of our displacement. So we have a velocity which is slowing down or decreasing. Speeding up and slowing down should not be confused with a positive and negative acceleration. All right, so here we have more examples with cars. So what we're going to do here is we are going to break down whether each car is acceleration, consider the arrows. The arrows represent the motion of the 5 cars. Consider the acceleration and velocity of each car in terms of its direction of travel. So go ahead and let's do car A first. So is car A accelerating? Is its velocity increasing? Is how would you describe its motion? Okay, so if we look at our arrows for car A, our first arrow is that big, our second arrow is a little bit bigger, our third arrow is even bigger, and our last arrow is the biggest. So these arrows, the motion, it's in the same direction as the car. So we would say that car A, has a positive velocity. Its velocity is increasing, and its acceleration is also positive. Now let's do car B. So how would you describe car B's acceleration and velocity? Okay, so again, take a look at the arrows, because car B is considered to be moving to the right of the paper, or the slide in this instance. It is moving with a positive velocity. However, because our arrows are getting smaller, our acceleration is in the opposite direction. Acceleration is negative. All right, now let's do car C. How would you describe car C's acceleration and velocity? Are they positive, negative, or neither? Okay, car C. Let's break down car C. Car C is moving to our right. Its velocity is positive. It's a positive velocity. And because all the arrows are the same length, car's speed is not changing. As a result, the change in its velocity is 0, which means that our acceleration is also 0, since we're not changing velocity. Okay, let's go on to car D. So how would you describe car D's velocity? And how would you describe its acceleration? All right, so car D. Car D is moving in the opposite direction. We are going to say that its velocity is negative, but it is speeding up. Our arrows are getting bigger in the negative direction, so its change in velocity is increasing, so its acceleration is also negative. And finally, let's talk about car E. So, car E, how would you describe its velocity and its acceleration? All right, car E, it's moving opposite to the positive direction. It has a negative velocity. Its velocity is going to the left, and our arrows, our velocity arrows down here, are getting smaller. So that tells us that our acceleration is positive. It is opposite the direction of the velocity. All right, that is all for tonight. Thank you for watching.